I guess software engineers are guilty of making life difficult for people as well sometimes. Like, it's quite common for software to output what's convenient rather than a format that can be ingested by another program.
All right, welcome everyone to another episode of the Bioinformatics Lab podcast. I'm Kevin Libuit with Andrew Page, and today we're talking about software bugs. Andrew, there's the side of bugs that, either introduced by the user by, erroneous error input and things like this, or there's also the side of bugs where it comes from the author's side and the software itself was maybe poorly developed or just, missed a detail along the way. So curious where you want to start this conversation.
Yeah, I guess bioinformatics software, a lot of it is academic quality. That's a term I've used many times before, and that's just more pilot projects rather than hardcore, heavily engineered and tested software. And so a lot of bioinformatics software doesn't have like unit tests. It's not properly engineered. It's more, PhD projects or master's projects that get they do well, but they're a lower quality than something that has that, that extra level of input. And then, that continues on into documentation. Some tools aren't very well documented. And, you get bugs. You get bugs in all software. And also you get a lot of user error. One of my favorites is someone will run a command, and they'll tell you it doesn't work. And it looks right. But it turns out they've gone and copied and pasted it into Word, and Word has gone and changed some of the characters, like the 66s and 99s, and in the Linux command line, obviously the actual fundamental characters mean something. So if it's a, forward slash or backslash, quote or whatnot, it actually means a lot. Or a dash, sometimes Word can put in, kind of an elongated dash, which is actually different character code. And then when you paste it onto command line, it doesn't work. But visually, trying to debug that is quite hard because it looks right. And so one thing that I've learned when debugging errors that people report is actually to type it out manually myself to get around these, like, is it a real dash or is it a word dash?
Absolutely. That's such a funny problem that we've all encountered so many different times. It's like whenever you see a software error, you kind of at a crossroads where you have to assume, is this user error or is this software error? Is this a bug in the code? And then so when someone presents it to you as an author, you're assuming you have to also make that same judgment call. Is this something they did or is this something I did? And often that's the first check though too. Like line endings, that comes to top of mind whenever it's like a multi-line input command. Ticks like single quotes that for whatever reason gets encoded differently once you pop it into Microsoft Word or something like this, and as you mentioned also like forward slashes. So like every white space and hidden characters, that's like where my eye goes first. Is this something they did or something I did?
Yeah, like the actually new line endings, is a good one because in Linux systems you'll often get like /n, like it's a character for a new line, whereas in Windows you'll get return. So it's the difference in like the old school keyboards, new line versus carriage return. And they actually fundamentally mean something different because they have different character codes in ASCII and the different operating systems use them differently. So you have to convert from one to the other. And sometimes, they'll put in both of them. And then, of course, OS X, which is Unix based, will do it slightly differently as well. So sometimes you have to convert between all three. And it can just be a bit of a mental exercise. There's software out there like DOS to Unix and Unix to DOS and stuff like that. So there is stuff out there to help you, but you just got to be mindful of things aren't 100% compatible always, even at a very simple level like a new line.
That this is such a funny conversation because we're talking about software bugs, but often whenever you get someone presenting with error, you just have to rule out everything that isn't actually a bug, but it's just on how you're using the software. And this was something that was a big deal maybe prior to the era of containerization, but also is knowing how they set up their environment knowing what dependencies they have. That was always a big part of the conversation too. How did you install the software? Do you have the appropriate dependencies? Is there something else interfering when you're actually calling the software itself? And that being ultimately user error.
Yeah, containers are great, but there is some caveats in there. So if someone says the base image to be like the latest of something, that can change. Versus say hard coding and saying, this is Ubuntu, 2404 .1, really locking it down, versus saying, oh, I just want the latest Ubuntu, and it's like, okay, great, that changes every few months. So you're kind of screwed with
Absolutely.
that one.
It's like turning over every little stone about what as a user have you done to actually get to this execution call, and that could be kind of a long journey just to make sure whenever you're presenting it to maybe the author of like, hey, I've tried everything. The best GitHub issues are those that document how you got to the error. The worst
Yeah.
ones are just saying, hey, I tried this and it didn't work. It's like, what do you mean by didn't work? But whenever you see someone really draw out the narrative, hey, I saw your software, I'm using this container image, here's the explicit command I'm using, copied out in Linux, and then screenshots of even the error code or maybe log files. It's like, okay, that person has done the due diligence to first and foremost rule out user error, and then it can present to you as an author, okay, this is probably a bug in the software that's worth checking out.
We're getting some unusual errors from being reported from users in a website we run, and it it turns out that you've got a sign in button, and beside it says request access, and so new users will come along and say, oh, I'll click sign in, not request access. So because there's kind of you can't directly sign up, so you need to request access for whatever reason, and that was causing issues because people were skipping that step, and then buried in these kind of platform as a service things, Auth0, it had, you can sign up here, and this kind of buried link, a few layers down, and people were clicking on that. Then I was like, oh no, this goes nowhere because it's not actually linked on our end. And so yeah, these weird errors were just this rogue kind of link that no one really thought about, buried deep inside, and because you expect people to click the other link.
I'm curious how you classify that in your mind as someone who's more on the software development side, because that's almost like a UI thing that kind of smells like a software error.
It is kind of it's a configuration error, I think, on my part, because I shouldn't have had the option there to allow for that. And then there's other errors, people not accepting, an invitation, verifying the email, whatever, and then trying to log in directly and then getting an error. And it's like, well, you haven't actually verified that your account is okay. But then, yeah, so that's another, kind of point of friction. And it's kind of a UX thing, as you say, but it's also a little bit of a user thing.
Wait, shared error. I'm curious though,
Yeah.
because we're talking about first of like, okay, someone presents with an error, and then I think it's first very fair to assume user error and ruling that out. It sounds like in this case, you were coming to that conclusion of almost putting yourself in the in the perspective of the user of like, why would they click this, or how did they get to this point, and that led you to debugging, in air quotes there, properly along the way.
Absolutely, yeah. But you get that in the lab as well, where you need to watch a process and, actually stand in someone's shoes, to see what's going on. So we had this very expensive tablet computer system, in the labs, to electronic notebooks, so you don't need notebooks. You just walk around with tablets. You take one from the end of the bench, you walk around, do your stuff, and then put it back. And I noticed one day that actually these are covered in dust because there's so little usage. It's like, okay.
Nice.
And then I realized, they're basically unusable. The way it had been set up by the corporate IT was actually that they don't actually work the way people in the lab work. People in the lab want to just, very quickly bang, log in, do their thing, take a photo, whatever, and write their stuff up. But this was blocking everything and was only allowing you to go to this thing, but not to everything else you might need. And so, just what it really required was, someone to stand in the lab and go, okay, what do you guys really need? And we'll allow that, rather than what does a corporate IT system think that you might need.
This is awesome too, because I think what we're talking about really is the principle of understanding the user and understanding their inputs and needs and endpoints, ultimate endpoints along the way, so that you can, anticipate the actual usage, and then you can develop the software in that use case, which can be often difficult whenever you're putting a tool out there in the general community, because you can't really anticipate everyone's use case. You don't know what everyone's data is going to look like. I think, in the pathogen genomics world, we're all kind of aimed towards assuming it's going to be Illumina paired end read data, but now there's more sequencing data, there's more caveats. Even in the pathogen genomics world, how they generate even that paired end sequencing data, especially in the viral world, is pretty diverse. People could be using hybrid captures, they could be using amplicons for targeted loci, they could be doing metagenomics. So it's like understanding the user will help to develop the software more appropriately, and then capture these different bugs that arise, and there's, I think we can go ad nauseum of the types of bugs that could really appear in software, because it's not always obvious. It's not always going to be something where the author is able to, print out an image of like error X. This is what's happening.
Yeah.
Oftentimes, it's the things you don't know that are under the hood until you get that variety of use cases from the wider user base there.
I guess software engineers are guilty of making life difficult for people as well sometimes. Like, it's quite common for software to output what's convenient rather than a format that can be ingested by another program. And so instead of spending the time, to maybe, I don't know, make a GFF file format, people might go, okay, well, I'll make up my own annotation format. And output that, and then you're into this kind of cycle of, okay, well, then the next person along who wants to use that has to convert it into something usable to get into ingest. And you have that quite a lot in bioinformatics, where you have a lot of different formats or incompatibilities, whereas us as bioinformaticians, well, we just want to chain all this stuff together, and just go bang 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 bang. We don't want to have to worry about these small little inconsistencies. If I put a pipe symbol, in the name of a sequence, will that crash the next program down the line? Actually, it does sometimes. And, so
Spoiler.
you want to be able to trust that what comes out is actually consumable. And software engineers, they'll make decisions sometimes which don't make sense. And it's usually because they don't necessarily understand how the software is going to be used or what the downstream processes are. And that's, I guess, a bigger picture.
Absolutely. It just speaks to the multidisciplinary aspect of bioinformatics, of understanding not only the software practices, but also the applications with respect to biological data. And then, furthermore into how the user is actually going to be using things. So this was a strong discussion. I think a million threads for us to pull on in future episodes with respect to software development practices to avoid bugs in your software to whatever degree possible, how to troubleshoot these things moving forward, and all the rest. But I think that's pretty solid for now. And we'll see folks in the next one.